So myself, Ayaz, and I'm going to discuss science technology, and I'm a faculty of science and tech at NEXT IAS. So the questions in Mains 25 from science and technology, which I'm going to take up, includes, this was one of the question number 5, paper number 3. This is about the fusion energy program in India. The first thing is fusion energy program in India has steadily evolved over the past few decades. Mention India's contribution to the international fusion energy projects. So this is another part, and what will be the implications of success of this project for the future global energy. So there are 3 parts to this question. So first and foremost, like this fusion reaction is also known as thermonuclear reaction. And this thermonuclear reaction, we all have grown up reading that it is something responsible for the energy of the stars and all. But to harness the energy of the fusion, to harness the fusion energy from the fusion to produce electricity, we have this fusion energy program. Now, in fusion energy, how to tackle this question? So this will be the backdrop. Okay. Now, to harness this energy, मतलब इसमें अब हम क्या लिखेंगे उसके आगे? That there are 2 ways to produce this electricity. One is the magnetic control of plasma. This is the second part of your question, and second is the laser inertial control. The example of the magnetic control of plasma is ITER, International Thermonuclear Experimental Reactor. इसको ITER कहते हैं. इस तरह से हम इस क्वेश्चन को बिल्ड करके चलेंगे. Now what is ITER? Magnetic control of plasma. So in ITER, if you see here, ITER. So ITER is basically about, now let's explain ITER. ITER is based on magnetic control of plasma. Now see plasma, what is plasma now? And then after that, if we are coming to the answer, we will explain plasma. That plasma is the 4th state of matter. So plasma is the 4th state of matter. Okay. And the principle of ITER is, now then I will explain what is the the basic principle of this ITER. The basic principle of this ITER is, whenever a charged particle enters the magnetic field, it moves either clockwise or anti-clockwise. Okay. Then after this, in this question, make a diagram of a tokamak. Okay, tokamak is like this. We have this a cylinder, and in this tokamak we have these magnets, and inside the tokamak we will heat deuterium and tritium. Then obviously it forms plasma. This plasma will form a donut shaped structure, and then there will be fusion. In ITER, the next part will be the input output ratio will be 1:10. So this is what we are looking, and this is how you will explain, because हमें 150 words में लिखना है, तो हम बहुत ज़्यादा यहाँ पर liberty नहीं ले सकते. Then the next part of this question is the next part of this question is India. India has Institute of Plasma Research, Ahmedabad. We have Raja Ramanna Center for Advanced Technology, Indore. And we have Saha Institute of Nuclear Physics, Kolkata. They are representing India at ITER. Besides that, Institute of Plasma Research has built Indian tokamaks. That is A. Aditya, B. Steady State Tokamak 1, C. Steady State Tokamak 2. So this is what we have done in India. Now what is India's contribution? India has contributed one more part here. India has provided cryostat and magnets for ITER. So that is our contribution and the evolution of Indian contribution to ITER. Then comes the third part of the question. The third part of the question is how it will contribute in global energy scenario. See, as far as global energy scenario is concerned, while writing answer, you need to link it with net zero. So it will help in the phase out of carbon based fuels. In other words, it will help in the decarbonization of the energy sector. That means it will help in combating climate change. Another thing, it will help in energy transition from fossil fuel based to clean energies. Okay, so this is what the focus of this particular question should have been. India, then explain ITER, then how India has contributed ITER, because India is a member of ITER. Rather, India is a full-fledged partner. Okay, means India is contributing in the same manner. If you see ITER, 45% is contributed by European Union, remaining 55% is equally divided among 6. One of the 6 is India. So India is contributing the same as US, Russia, China, Japan, South Korea. That's it. That is about ITER. If you can mention the bit of the challenges, like the temperature plasma here has to be 150 million degrees Celsius. You can mention other international projects also, like east of China. Then you can mention K-star of South Korea also. So that will probably make your answer, very, very broad based, quite comprehensive. Okay, fine. So this was about ITER. Then we will move to the Next question. The next question here is how can India achieve energy independence through clean technology by 2047? How can biotechnology can play a crucial role in this endeavor? So it's a 10 marker, and if you see it being a 10 marker, then there are two parts of it. First part of this question is energy independence. Energy independence means what? Energy independence means addressing first in this question. Let's talk about energy independence. Define energy independence. That all our needs, all the needs at our own. That electricity which is 24/7, which is cost effective, which is environment friendly. That is energy independence. Now the question is how India can achieve energy independence through clean technology. So after this, let's talk about the next part, the clean energy technology. Now clean energy technology, first if I will be writing the answer, I will be mentioning nuclear energy. Nuclear energy, and here you should have mentioned the nuclear mission, nuclear energy mission of 100 gigawatt, 100 gigawatt by 2047. Now, while writing this nuclear energy mission, here we should mention a small modular reactor. Here we should mention thorium based technology. Thorium based technology. Like how thorium, like India has a lot of thorium, so if we can use here, we can really contribute a lot in our energy production. This is going to be the first part of clean energy technology. The next part of the clean energy technology will be this is okay. So next part will be renewable energy. Now renewable energy here, you should mention some of the panchamrits. That includes 500 gigawatt of non-fossil electricity by 2030, 50% of total electricity from non-fossil sources by 2030. Then after this, after mentioning these two, okay, what we can really add here in this question, bring third part of the answer, that we need to integrate renewable energy systems, and for this purpose bring into your answer green energy corridor. Green energy corridor is to link these renewable energy production centers with the power grid, and the other part which we need to integrate here is the smart grid. Now clean energy technology here, then you can mention some of the initiatives taken. One of them is the rooftop solar, then PM Kusum. Then you can obviously bring into your answer that energy storage system we are talking about. That includes battery energy storage system, that includes pump hydro storage in your answer. Then you can also bring into your answer the PLI scheme for the manufacturing of the solar panels. Okay, Then this is first part. I think this much we can do here. Then after this, there is another part. How biotech can be used. Biotech. Role of biotech. So here, first and foremost, in this particular part of the question, you can mention Bio E3 policy. Bio E3 policy, biotechnology, environment, economy, and employment. In Bio E3 policy, we are talking about biofuel production. Biofuel production. Second thing, other than this biotech, we can talk about is synthetic genome. In synthetic genome, we are looking to have bacteria that can convert carbon dioxide into biofuel. Then after this, you can bring one more thing, algal fuel. Algal, which is fuel, and here we can genetically modify this algae to increase the oil content. Then one more thing you can bring here, the Nobel Prize in Chemistry for the year 2024 to David Baker for designing new proteins which are capable of converting carbon dioxide into biofuel. So 150 words, this much we can write. Okay. Then other than this, there is another question. Question number 3. How does nanotechnology offer significant advancement in the field of agriculture? How can this technology help to uplift the socio-economic status of farmer? So first and foremost, nanotechnology. The second part is advancement in the field of agriculture. And second part is uplift the socio-economic status of farmers. So this is a bit open-ended question. It's not very straightforward question. So here, first and foremost, like nanotechnology, we will go for. Nanotechnology is the manipulation of matter at the fundamental scale. Then mention Richard Feynman. There is plenty of space at the bottom. Plenty of space at the bottom. Okay. Then we will come towards applications of nanotechnology in agriculture. The first application here is nano fertilizers. Nano fertilizers like nano urea. Now here we will give the benefit of nano urea, that it will have greater absorption by the plants. Okay. Then nano fertilizers, after that we can use nano sensors. Nano sensors for precision agriculture. Precision agriculture. Then one more application we have is nano pesticides. nanopesticides will help in crop protection. Now besides this, what all other things you can write here? Fourth application of nanotechnology, we can have nano UAV to monitor the crops. Then we can also have other applications like you know we can also write the nano remote sensing satellite to provide weather information to help the farmers. Then comes to the next part of the question: nanotechnology and socio-economic upliftment of the farmer. So answer is very simple. By using nanotechnology, we can enhance the shelf life of the products. So if we can enhance the shelf life of the products, so farmers will get a good return on their production. Second, it will increase the productivity. It will reduce the consumption of fertilizers. It will reduce the consumption of pesticides. Somewhere all of them put together will improve the quality of life of these people. Okay, so this is how the socioeconomic part will come into play. We can use this nanotechnology in food processing industry. That will also help the farmers in improving their economic condition. So this should have been the focus part. One more area where obviously they have gone for a bit of an open-ended question. Now one more question which is left is this. Now this is a question: India aims to become a semiconductor manufacturing hub. What are the challenges faced by the semiconductor industry in India? Mention the salient features of the Indian semiconductor mission. Those semiconductors, first let's talk about semiconductor. Okay, the semiconductor manufacturing hub. So first, uh, semiconductor has emerged as a new tool of geopolitics. So in this question start by explaining the importance of the semiconductors in the current era, and they are becoming a tool of geopolitics. Then we will explain here. The semiconductor attributes like the node size. Then in this question explain advanced nodes and legacy nodes. What are advanced nodes and what are legacy nodes? Then explain why India is looking to be a manufacturing hub. Because this is going to make India a digital, it's going to contribute India in becoming a digital economy. Now listen here, there is one more part. Why India? Because without semiconductor, you cannot progress in the field of AI. Why India is focusing on? Because without semiconductor, you cannot manufacture electronic equipments. Why India? Because semiconductors are required in robots, and the semiconductors are required in defense items as well. That is how India, that is why India is trying to become a manufacturing hub. Now, to become a manufacturing hub, India has taken, many initiatives. One of the initiative is the PLI of $10 billion, $10 billion under Indian Semiconductor Mission. Here there is a provision of 50% subsidy on capital expenditure. And here under this program we have 5 projects. 4 of them are ATMP, assembly, testing, marking, packaging, and 1 project is a fab unit. Besides PLI, we have one more scheme, DLI, that is design linked incentive. Design linked incentive, again there is a 50% subsidy. There is a 50% subsidy for setting up a chip designing unit. And the plan is in the next 5 years, have 20 companies with at least 1500 crore turnover. Okay. Besides this, India and USA have this trust mechanism. In that also, India and US are collaborating in semiconductor manufacturing. Now, after that, the next part of this question is, the next part of the question is the challenges faced by Indian semiconductor industry. The first challenge is the entry barrier is very high. Entry barrier is very high because 26% is the capital expenditure, 22% is R&D expenditure, put together 48%. And here the technology is continuously evolving. As the technology is continuously evolving, you need to have continuous R&D also. So it's not like you can sit on the past achievements and you can keep on growing. The second challenge we have is to make semiconductor, we need uninterrupted supply of electricity. You need human resource and supply of water, as well as an ecosystem. Ecosystem means you need gas, you need lasers, you need the supply of the wafers. So that absence of ecosystem is also one of the things. Another reason or another challenge we are facing is lack of domestic R&D. We don't have our own R&D. Another reason, another challenge we are facing is that lack of robust electronic manufacturing. Because see, why these companies like TSMC or Nvidia will not come? companies like TSMC and NVIDIA are not coming because we are not manufacturing the latest electronic gadgets like the iPhone 16 or the Samsung S24 Ultra or the Fold mobile of the Samsung, these things. So if we can have this type of electronic manufacturing, then there will be incentive for these semiconductor manufacturer to bring the latest node size technology in India. Otherwise, we'll end up making only legacy nodes. Like India is focusing on 28 nanometer, 40 nanometer, 55 nanometer, whereas the Samsung and TSMC, they're already making the 3 nanometer node. So these are the major challenges, and the benefit will be, obviously it will contribute in our indigenization of the technology. It will create an ecosystem, and no doubt it will create a lot of jobs and obviously digital economy. So thank you very much. These were the science and technology questions which I was supposed to discuss with you. Okay, all the best. Thank you.